Hello friends, welcome to Aravalli Geo Academy. Today we are going to discuss the next part of the climatology. Today we are going to discuss the Earth and its atmosphere. Next part, okay. We have already covered origin of atmosphere and composition of first and second atmosphere and composition of the present atmosphere and about the CO2, okay. And so we already know the greenhouse gases are the water vapor, CO2, methane, nitrous oxide, and other, okay, CFC. So methane level rose about of 0.5% per year in the 2010, okay, after a slower rise earlier. Okay, so remember the methane level rose about 0.5% per year in 2010 and after that slower rise earlier. Okay, major methane sources are include rice paddies, wet soil, termites, cow digestion, and natural gases. Okay, so also remember this point. What is the source of the methane in atmosphere? Okay, methane come from the rice paddies or waterlogged soil or wet soil, as well as the termites and cow digestion. Okay. Uh, Methane also adding through the volcanic or natural gases leak. Okay, volcanic process or natural gas leak. Nitrous oxide level are rising at about 0.3 percent per year. Okay, remember methane rise 0.5% per year and nitrous oxide rise 0.3 per year. And you tell me the CO2 increasing rate of the per year in comment section. We have already covered in the last lecture. So nitrous oxide come from the industrial byproduct. Okay, nitrous oxide is the industrial byproduct. Okay, and soil process involving microbes. Sunlight ultraviolet ray break down the nitrous oxide in the atmosphere. So sunlight, especially ultraviolet, break this nitrous oxide into the atmosphere. Okay, and chlorofluorocarbon is also a greenhouse gas, or chlorofluorocarbon is not a single. This is the group of the greenhouse gas. Okay, so CFC concentration increased until the mid 1990. Okay, after that this was banned, so the concentration is not increased. They were once widely used in the spray can propellant. This was used in the actually spray before the 1990 as a propellant. CFC were also used in the refrigerant or foam insulation as well as the electronic cleaning. Okay, so remember this was the use of the CFC before the 1990. This was used for the spray and propellant as well as the also used in the refrigerant or foam insulation as well as the electronic cleaning. CFC trap heat and destroy the stratospheric ozone. CFC is harmful for the ozone because this was destroy the ozone. Okay, and this ozone actually present in the stratosphere, and stratosphere height is 11 to 50 kilometer. Okay, remember this point. The height of stratosphere is the 11 to 50 kilometer. Stratosphere lies just above the troposphere. Okay, and CFC have been largely phased out by the Montreal Protocol. We will discuss in upcoming slide about the Montreal Protocol. Okay, this was related to the ozone depletion. Okay, HFC replaced by CFC and do not harm the ozone but are the strong greenhouse gas. Okay, in the Montreal Protocol, this CFC was completely banned. Okay, but HFC used as the place of the CFC. So this HFC not harmful for the ozone, but this is a strong greenhouse gas. Okay, so we will discuss about the Kigali Amendment and this Montreal Protocol. First, we discuss the Montreal Protocol. So, this Montreal Protocol actually related to the ozone depletion. Okay, in this Montreal Protocol, chlorofluorocarbon was completely banned. Okay, this protocol was signed in 16 September 1987. and location was the Montreal. Okay, this is the location, and this Montreal Protocol was effective by 1 January 1989. Okay, so this Montreal Protocol signed on 16 September. So we are actually celebrating 16 September as a Ozone Divas or Ozone Day every year. So remember, Ozone Day celebrating every 16 September. Okay, because this day on this day this Montreal Protocol was signed. Okay, also remember the date of the sign or effective date. Okay, 1st January 1989. So CFC was banned in this protocol, but HFC hydrofluorocarbon was not banned. Okay, so in the Kigali Amendment, this was signed in uh, October 15 October 2016, and CFC was also banned in this Kigali Amendment. Okay, this was actually signed in the Kigali. This Kigali is the capital of the Rwanda. So also remember about the Kigali Amendment. This is related to the HFC, and Montreal Protocol related to CFC. Okay. Also remember location and effective date 1st January 2019 and sign date uh, 15 October 2016. The Kigali Amendment 2019 aimed to phase down the HFC, or this Montreal Protocol aimed to the phase down CFC. Okay. Or the target year also remember for HFC 30 year. Okay. Now next, the ground level ozone is a main component of the photochemical smoke. We will discuss later, okay, type of the smoke, okay. So I will teach you the industrial smoke and photochemical smoke. But remember, ozone is the main component of the photochemical smoke. This was part of the exam. Examiner directly asked you, what is the main component of the photochemical smoke? So correct answer is the ozone, okay. And this photochemical smoke is harmful for us. Photochemical smoke actually affect the eyes, okay, as well as the throat irritation and vegetation decay. So also remember the effect of the photochemical smoke or main component of the photochemical smoke. uh, the 97% atmospheric ozone actually present in the stratosphere, or this ozone formed through the combination of the oxygen atoms. Stratospheric ozone actually the concentration of this stratospheric ozone is very less. Okay, 0.002% only by the volume. We already know the maximum part of our atmosphere is the nitrogen and oxygen, or 99% part of the atmosphere is only nitrogen and oxygen. So this concentration of ozone is very less, 0.002% only by the volume. Or this ozone actually very important for us, because this is protect the life from the harmful ultraviolet ray. Ozone absorb the ultraviolet ray and protect us. Ozone is harmful at the surface. Okay, ozone harmful at the surface but very essential for the stratosphere. Okay, because this is the shielding the life on earth. This is after the absorbing the uh, ultraviolet ray. Chlorofluorocarbon release the chlorine in atmosphere, and this chlorine is actually harmful for the ozone. This chlorine destroy the ozone molecules. Ozone level drop in the late 20th century, especially over the southern polar region or near the Antarctica. So in which month, in September or October month, this ozone level is ozone thickness is very low in the southern polar region, and this is the seasonal ozone hole formed above the Antarctica due to the stratospheric ozone depletion. Okay, so remember the name of the season. In the northern hemisphere, this September October month is actually the autumn season, but in the southern hemisphere, this season was the spring. So examiner directly ask you, ozone hole near to the Antarctica form in which season? So in the spring, because in September or October month, actually spring season in the southern hemisphere. Okay, or autumn season in the northern hemisphere in this time. So see, this is the ozone depletion. Okay, ozone hole, because ozone thickness is around the 200 Dobson, or this red color indicating the ozone concentration is greater, approximate 500 Dobson. Okay, and volcanic eruption emit the ace, water vapor, and CO2 and SiO2 into air. Okay, this suspended particle is known as the aerosols. Okay, the tiny suspended particle into atmosphere is known as the aerosols. Okay, tiny particles like ace, water vapor, etc. So Dobson, remember about the Dobson. Dobson is the actually unit of the measurement of the ozone thickness, and 5 Dobson equal to 5 mm. Examiner directly asks you, actually 700 Dobson is equal to how many mm? So 700, if I ask you the 700 Dobson equal to how many mm? So 7 mm, or 500 equal to 5 mm, 1000 equal to 10 mm. So remember this one also. Floating particle have to water vapor condense to the form the clouds. Okay, I will tell you later how cloud droplets are formed. So but remember, this floating particle or this aerosol is very important for the water droplet condensation. Okay, because this floating particle provide the platform for the condensation of okay, to the form cloud, and after the formation of the cloud droplet, okay, clouds are formed. So older car engines emit nitrogen dioxide, carbon monoxide, and hydrocarbons. Okay, and this nitrogen dioxide react with the hydrocarbon and form the photochemical smoke. Okay, I will tell you later. Actually, lots of the smoke like the industrial smoke, sulfur smoke, or photochemical smoke. Later we will discuss in other chapters. So carbon monoxide is also a major urban air pollutant. Okay, carbon monoxide is a major urban air pollutant. Okay, see, this is the volcanic eruption, and there are the lot of aerosols add into the atmosphere, and lot of harmful gases is also add into atmosphere. So this carbon monoxide is the colorless, odorless, or poisonous. Okay, remember this one. Carbon monoxide is a poisonous gas. Okay, and it is formed through the incomplete combustion of the carbon-based fuel. Okay, this carbon monoxide formed through the incomplete combustion of the carbon-based fuel like diesel and petrol, etc. Over the half of the urban CO2 emission come from the vehicles. Remember this point. What is the source of the carbon monoxide? Vehicles. Burning of sulfur containing fuel release sulfur gas into the air. So what is the sulfur containing fuel? Like the coal. After burning of the coal, this sulfur release into atmosphere. Okay, and this sulfur gas form the sulfuric acid. Okay, and this sulfuric acid droplet come through the rainfall. Okay, and nitrogen dioxide also form the nitric acid droplets in atmosphere, or this nitric acid and sulfuric acid come through the rainfall on the surface, and this is corrode the metals and damage the paint of the buildings, as well as the acidify the lakes, because this is acid. Okay, particulate matter include tiny solid and liquid particles suspended in the air. This is part of the actually a type of the aerosols. So particulate matter include tiny solid or liquid particles suspended into air. Remember the definition. These particles can reduce the visibility. Okay, if concentration of these particles are high in the atmosphere, then visibility will reduce. Okay, particulate matter can cause the respiratory and cardiovascular issue. So in the AQI, air quality index, we will discuss the two particulate matter, PM10 and PM25. Okay, PM10, it means particle size is less than or equal to 10 micrometer, or uh, PM 2.5, it means particle size is less than or equal to 2.5 micrometer. Okay, both are actually measured in the AQI, air quality index. So this is also important. Or remember the definition first. The particulate matters are the solid or liquid particles suspended in the air. Okay, so thank you so much all about this video. We will discuss the vertical structure of atmosphere in upcoming videos. So try to share these videos those students preparing for the CSIR NET, SET or other geology related exams. So thank you watching for this video again.